Hi, everyone, and thank you for joining us today. We're Team 52, and we're excited to introduce you to TransitGuard, a real-time AI-powered platform designed to enhance safety across the CTA, Chicago's public transportation system. My name's Sergio, and I'm here along with Kevin, Derek, Summer, and Sophie. And during this presentation, we'll walk you through our analysis of the current state of the CTA. We'll give you a demo of the TransitGuard solution, and we'll hopefully demonstrate the real impact that TransitGuard can have on the lives of transit passengers. Is your daily commute safe? Imagine boarding your usual CTA train and you're trying to get to work or to school, only to be confronted by violence. Just last year, a 17-year-old robbed and beat 4 passengers in a single day. And in the most tragic cases, passengers were shot execution style while they slept. These stories aren't just headlines, they're real experiences that show why we need a better solution to keep CTA riders safe. So let's talk about the core problem that we're trying to solve. The CTA serves more than 950,000 riders every weekday across 128 bus routes and 8 train lines. It's the second largest public transit system in the country, yet one of the biggest challenges it faces today is safety. Based on Chicago crime data and crimes that happen related to the CTA, the crime rate per trip has tripled since 2015. That means riders today are significantly more likely to encounter a safety incident than just a decade ago. On average, we're seeing more than 4,600 transit-related crimes each year. And that's not just a statistic. Those are real risks that riders face every single day. Unfortunately, the system today is still reactive, not predictive. There's no consistent way to anticipate where or when these crimes will occur. And in a city where public transit is essential for millions, that kind of gap in safety isn't just inefficient, it's dangerous and it's outdated. So, to address these safety challenges, we've developed TransitGuard, an AI-powered safety intelligence platform designed specifically for public transit. TransitGuard helps move the CTA from reactive response to proactive prevention by using advanced data science and real-time systems. First, it predicts crime risks at individual stops and stations, allowing security teams to anticipate where problems are most likely to occur. Second, it uses spatial clustering with DB scan to identify high-risk geographic zones like the downtown loop or major transfer hubs, so that city officials can better allocate resources. We also apply time series forecasting with SARIMA and classification models like logistic regression to uncover crime trends and anticipate spikes. Finally, TransitGuard delivers all of this through a real-time dashboard, a mobile app with automated alert systems, and a generative AI chatbot that lets riders ask questions and get instant safety updates. In short, TransitGuard is more than a dashboard. It's a comprehensive predictive safety system designed to protect riders, improve response times, and rebuild public trust in transit. And with that, I'll pass it over to Sophie.
Thanks, Sergio. Now that we have introduced what the TransitGuard is and then what it's aimed to do, let's walk through how we get there. First, we analyze the CTA-related crime data and the CTA ridership data from 2011 to 2024 to uncover the key safety trends across the system. In the figure on the left, we show total the CTA crime and the ridership by year. Both dropped sharply in 2020 during the pandemic. But what stands out is what happened next. Crime rose faster than the ridership, meaning that the risk per rider has gone up. In the figure on the right, we break down the most common type of the CTA crime. Theft, battery, and robbery are the top 3, making up about 60% of all reporting incidents between the 2014 and 2024. This finding emphasized the importance not just checking the crime volume, but understanding where and when risk is highest, which is exactly what the TransitGuard was built to do. Now, let's look at how the crime and the ridership follow the similar time-based pattern across the CTA system. The figure on the left, we compare the average daily boarding for bus and rail, which is trend on the weekdays versus weekend. As expected, weekday ridership is much higher, especially for the bus, which averages over 700,000 rides a day. Trends show a strong weekday pattern too, which suggests that the commuter traffic is a major driver of both usage and the risk. The figure on the right, we shift from the daily to monthly trend and look at the crime count by month. July and October consistently rank among the highest crime months. This matched the broader ridership pattern in the public activity during the summer and the early fall. Even after summer, crime level stayed relatively high through the fall, which point to the needs for the seasonal safety planning, not just focusing on one busy month. Together, this pattern shows that the crime risk track closely with the ridership and that the time, both day type and seasons, should be built into any predictive safety model. That's exactly what the TransitGuard is doing. So after understanding when the crime are mostly likely to happen, the next step was to figure out where they are happening. And that brings us to the crime locations. In the figure on the left, we look at the type of the location tied to the crime report from the 2014 to 2024. CTA, train, bus, and platform are the top three. Even though the bus carry more rider, train and platform are more incidents, which means this area should be a higher priority for the staffing and surveillance. In the figure on the right, we have the map showing where the crime and are clustering across the city, as expected. There is a clear concentrations in the central train corridor and then the downtown area. All of this reinforce what we have been seeing. Crime is not even spread. It's focusing in the specific higher traffic location. Together, these findings support the TransitGuard's approach. We not just reach to the right crime number, we are targeting based on the location, time, and the actual risk. TransitGuard is also including the content of the traffic crash incidents. This addition gives the CTA passenger, especially the bus rider, a more complete understanding of their overall trip safety. On our analysis of the Chicago traffic crash, data showed that the number of the traffic crash incidents between the 2017 and then 2024 is a trend upward. Even when the accounting for a dip in the car travel in the 2020 during the COVID-19 pandemic. In this map of the Chicago, we highlight the street with the most traffic crash incident between the 2017 and 2024. Western Avenue, which is the longest continuous road in the city of Chicago, sits on the top at the top with the 23,314 traffic accidents during the 7-year span. While downtown shopping corridor Michigan Avenue and the State Street run around the list. Passengers who regularly ride the bus on this street, like the 49 bus on the Western Avenue or the 53 bus on the Pulaski Road, should be especially cautious when using these routes.
Thanks, Sophie. I'm going to talk about the modeling part of the project. So in order to explore CTA crime seasonality trend to forecast the future crime incidents, we first use SERIMA modeling method, which is a widely used time series forecasting model. The key strength of this method is to identify the repeating patterns in the data for seasonal trend. We first separate the crimes into the violent and property crimes to better study the categories of incidents that will be most concerning to riders. As we shown in the investigation section before, that we noticed the crime number is highly correlated with the total ridership. So to account for the crime incidents and ridership relationships, we here normalize the crime number per 100,000 rides to observe and forecast the crime incident rate for both the violent and property crime categories. The top feature is for the violent crime category that we observed a sharp spike of violent crime incident rate during the pandemic years. Although the rate drops in post-pandemic years, the violent crime rate trend is still higher comparing to the pre-pandemic years, as you can see, and it stayed the same higher trend in the future 12 months according to Serima prediction. And the bottom feature, you can see the figures for the property crime category, and we observed a similarly sharp spike during the pandemic years. But interestingly, the property crime rate trend kind of drops back to the pre-pandemic level afterwards, and it stays the same trend in the near future 12 months. So these two figures tells us that the violent crime rate has pretty different seasonal patterns from the property crime category. The similarity between these two crime types is that they spike during the pandemic periods. But for the non-pandemic year trend, it seems that the property crimes are more dependent on the total number of riders. So in other words, for property crimes, they are more opportunistic and the number of crimes scaled with the total number of riders. However, for violent crimes, the number of crimes are less dependent on the total ridership, but more dependent on external factors such as gang warfare and personal grudges. And we also explored seasonal patterns in smaller time scales, such as daily and weekly crime rates forecasts, which are not shown here. And we found that those time scale, the data noises were too big. And so we decided to continue to use the monthly time scale for our future modeling. Our next step of modeling would be identifying a predictive model that can most accurately calculate the crime incident rate. This model will allow us to predict the future crime number given the total ridership at a given time. We first start with testing recurrent neural network RNN model, which is one type of neural networks that's specifically used to process sequential data like ours. We split our data into 80-20 training and testing, and categorize the crimes into two major types, violent and non-violent crimes, so that all the crime types are included here. We also normalize the crime number per ride so that it counts for the influence from total ridership as we observed before. So the left feature we can see is for the violent crime, and the right is for the non-violent crime for the RN modeling. You can see that the forecast for the monthly crime rate for both of the crimes do not align pretty well with the actual monthly crime rate. And this is after adjusting several parameters as well as trying different time scales. So we think this is because of the nature of the long time period and complex seasonal trend in this data set. So therefore, we decide to move on to test a more advanced RNN model, which is called long short-term memory, LSTM, which can handle more advanced sequential data tasks and is better at retaining information from earlier time steps. For LSTM model, we also did training and testing data split with 70 and 30% and split the crime into the same violent and non-violent categories. We also did the same normalization as in the previous RNN model. As you can see that the left figure is for the violent crime and the right figure is for the non-violent crime. Both of our training prediction and forecasting align pretty well, and which is much better actually, to our actual crime rate per ride comparing to our previous RNN model as shown before. So this LSTM approach gave us a more accurate forecast for both major crime categories for the crime rate time series, and was able to forecast a generally more accurate seasonal cycle for the crime rates. Although you can still see that it was not able to predict some of the peaks in the crime rates that exceeded the previous peaks, such as those peaks during the pandemic times. But in general, it was able to forecast a much more accurate level of crime rate. So therefore, we can conclude that the LSTM is the optimal modeling approach to predict the future CTA crime rates, which we've been able to convert it into powerful features for our users in the TransitGuard dashboard that we're going to talk about in the future.
Let's jump into our demos. So we have 3 core features that we've built that we'd like to show to you today. One being TransitGuard dashboard, the TransitGuard mobile app, and the generative AI retrieval augmented generated chatbot that we added to both dashboard and the mobile app. So rather than showing you some slides and talking through it, we're going to show you how those apps work, and we're going to demonstrate the functionality and show you how everything ties together. But first, let's review some of the data architecture and the architectural diagrams that show everything connects. So this diagram shows how TransitGuard brings together everything to keep riders safer. We start on the left, we have our 3 key data sources: crime data, ridership data, and traffic crash reports. These are updated regularly from public sources like the City of Chicago's open data portal. All this data flows into our ETL pipeline, which is built in Python, where we extract, clean, and transform it, removing all the noise, handling missing values, and enrich it with time and location features. From there, we split into 2 paths. First, our data goes through our modeling engine, which Summer was talking about, to make predictions about crime and safety incidents across the CTA transit system. And then we use forecasting methods like SARIMA and LSTM and logistic regression to predict that risk by location and time. And second, we take those predictions and insights and analytics and feed them into our interactive dashboard in a mobile-friendly app and our generative AI chatbot that can help users to converse with the data in a conversational manner. All these tools are interconnected so that the alerts from dashboards are synced with the app and the chatbot, ensuring riders and officials have the most current risk information at their fingertips. So first, I want to look at the TransitGuard dashboard. We have several core features, but instead of looking at this slide, let's look at the dashboard itself. So with that, I will open our app. So this is the TransitGuard real-time safety dashboard. We envision this as being a back-end system for internal users. And this could be made available publicly, depending on the appetite for sharing this level of interactivity with the data. So the first feature in their dashboard is our safety index, which you can see right here. This is a custom algorithm that we created that scores the safety of the entire CTA system. So right now you can see that the entire CTA system for this day is currently scored for 50. Just happens to be at right in the middle. So 50 on the low end would be a 0, and that means that the safety is really bad. And at the high end, 100 means that the safety is really good. So you can see right here at 50, it's right in the middle. We can also see below that we have a metric that compares it to the previous 7-day average. So we can see that 50 is actually a 10.5 improvement from the previous 7-day average. Now this safety index score updates in near real time. So anytime there are new incidents in the system, then this score will update to reflect that new system status. And the system status is collected every day, and as is the safety index. So the user will be able to investigate the changes in the system over a period of time. And as a note, and a contextual note into the dashboard that we're looking at, that we decided to showcase the data on July 13th, 2024, as you can see in the upper right-hand corner. This was so that we can illustrate all of the features within the dashboard, because on any given day, there might not be any crime incidents, there might not be any traffic crashes or incidents on a particular line. So we chose this day to illustrate that all the core functionality. But in a real-time case instance, a user will be able to see the current day and be able to navigate to other days and see the trend lines over a period of time. So next we have the total crime incidents. This shows for any day, what are the total incidents, crime incidents that have happened? And as we can see here, there's 4 battery, 3 robbery, and 6 other. If we click on the other, we can see what those 6 are comprised of. 2 assault, criminal damage, 1 theft, and weapons violations. All sum up to the total of 13. And the same thing with the safety index, we can see a comparison between the previous day. So a 13% decrease from yesterday. And then the last one on the top row is this traffic crashes card. So this shows the total number of traffic crashes throughout the day. And like the other cards, this will dynamically update throughout the day. So as new traffic crashes come through the system, we'll see this updated. And you'll see this further breakdown, which can show the number of fatalities, number of incapacitating injuries, and the number of non-incapacitating injuries. It doesn't total all these 3 categories, don't sum up to 365, because a lot of these other crashes don't have any of these categories associated with them. So we can add additional functionality in the future if the analysts and developers decide that they want that. So next is the safety incident map. So the idea behind this is to provide a dynamic and interactive interface for the user to look at this map and be able to see what is happening at any given point in time, where a user can zoom in and be able to click on individual incidents and see what happened at what time on this particular day. And it also has a feature, currently we're looking at the last 24 hours, but you can also look at last 7 days, last 30 days, and future versions might have the ability to scale down even farther to be able to look at the last 3 months, 6 months, a year, and be able to see where traffic and crime incidents are located. We also included a color legend here at the bottom to show the levels of risk based on the amount of crime or incidents in a particular location. It is important to note that this map includes crime and traffic related incidents. So it has this total number of 13 plus 365. And so green being the lowest risk, yellow medium, and red high. So you can see that most of the incidents are happening in Chicago, near the city of Chicago, which checks out with our initial analytic findings. So this being a first version of this map, we can add additional functionality in the future to be able to isolate between crime and traffic incidents so that the user can differentiate between those more easily. The next feature that we have in this dashboard is a line status. This shows how many incidents happened on each of the transit lines, and we have an associated flag to identify the level of risk associated with each of those. That depends on how many incidents happen in the last 7 days. So as we can see here, the red line from July, based on July 13th and the prior 7 days before that, there's been 31 incidents. The second blue line has 11 incidents, and both are flagged as a medium risk because of the number of incidents that have happened there. And the 2 lowest are the purple line and the yellow line because they've only had 1 in the last 7 days. And these incidents could be these incidents are only related to crime at this time, but they could have additional functionality to be able to toggle between crime and traffic incidents in the future. And so this medium and low and high flag, you notice that none of them are currently high risk, and that's because none of them met the threshold to be classified as high risk at this time. Just as in the safety index card, we're looking at all historical data, and we're looking for, in order for it to hit high risk, it has to meet above a certain threshold related to the standard deviation based on the median number of incidents for any one particular line. The next feature that we have within the dashboard is our predictive analytics table or plot. Now, this plot shows what the actual crime incidents were over the last 10 months, and the predicted crime incidents for the last 10 months, including the next 2-month forecast. So as you can see here, you're looking at our current date, that the predicted crime incidence is 351, but our current crime incidence is 152, and that's because we're in the middle of the month. It's July 13th, and there's still half the month to go. So as we go throughout the month, we'll see that this number, we expect this number to rise. It's also important to note, as you can see here, that the forecasts are not exactly accurate. There is, at times it comes really close, and others for the last, I'd say, 6 months, that there's been quite a gap. And so as we're collecting more data, as we're perfecting our models, we fully expect that this gap to decrease and our models to be better at predicting the number of crime incidents, as Summer mentioned. As we fine-tune our LSTM models, we'll get better at predicting what crime is likely to happen, when and where, so riders can make more informed decisions. And it's also important to note that this graph we're looking at, this is a first version of what could be. And there's a lot of other graphs that we can add to this to help inform analysts and to be able to, and riders to be able to make more informed decisions. So as we start to roll this out and collect data on what users want and what they're using, we can make updates to this dashboard to reflect those requests and desires from the user base. So lastly, we have our GenAI chatbot. So we also have this in the mobile app, and I'm going to wait to demonstrate this until then. But the mobile app is available in both, and I just wanted to show its functionality in this instance. Okay. So with that, we can move on to the mobile app. And like the dashboard, I won't spend time on this slide. Instead, we'll go right into the demonstration. So here is our TransitGuard mobile app. And as you can see on this first page, it's very similar to the dashboard. Actually, it's exactly the same, except for this quick actions tab on the bottom. All of this is meant to be a one-for-one with the dashboard so that the users can see what the safety index is, total crime, to help them get an idea of what's going on in the system. This is also customizable, and we thought that this is a useful landing page for users to see when they download the app, when they interface with it, and also adding these quick actions at the bottom to allow users to report incidents and view alerts with relative ease. I won't go into explaining these because we explain in the dashboard. So with that, we'll move on to the next tab, the map. And this is also the same as the dashboard. We have this interactive map that users can scroll through. They can click on individual incidents. They can see this color coordinated plot to see what are high risk areas and safe areas based on the number of crime incidents that have happened in the last 24 hours to help them make more informed decisions about where they want to travel or what lines they want to take. And below that, the nearby stations is a new feature that's specific to the mobile app, where, like many other apps that you can download on your phone, you can give an app the ability to know your current location. So if you do so, then this feature will update with the stations that are most near to you, and it'll have the number of incidents. So you can see it currently today also the same as in the dashboard. We chose July 13th, 2024. There were 0 incidents that happened on any of these lines that are close to the user. And in this instance, I think we chose Northwestern University campus. I believe it was the Chicago campus. And we also have this green status to indicate that there's a very safe area currently. And if there's, just like the dashboard, if there are any new incidents that happen in the area, this would be reflected accordingly, and the user would then see the incidents pop up here on this tab, and they can click on it to get more information about it. So next, looking at their report tab, we made a interactive submission form for users to be able to report incidents that they see on the CTA. And something that we read from writers of the CTA was that there seems to be a gap between reporting incidents and response from police. And so we're aiming with this app to make reporting those incidents easier and coordinating with our local law enforcement to improve the response time. So we hope that by collecting this data, we can be able to track not only when these reports are submitted, the location, the incident type, and description, and we can include this information in our app on a more real-time basis instead of pulling data from the CTA API. We also include some reporting guidelines. There's some best practices for writers on what to report, how to report it, what to do if there's an emergency situation, which is always call 911 directly if there's an immediate threat to yourself, your person, or your property. And then more information for CTA safety resources. So then, in partnership with the reporting and the nearby stations to you, you can sign up for alerts. So like other apps, we have push notifications and also nearby alerts only. So if there's something that's happening in close proximity to you, a feature that you can set yourself as to the proximity of alerts in your location, you can get real-time alerts to say, okay, there's an incident happening, one stop away from you. There's an armed individual. There's a burglary in process. Maybe best to avoid that location at this time. So the idea was to allow riders to, again, make more informed decisions and not to be so reactive, and to help them navigate their journey on this Chicago transit lines. And this next feature down here, you can set up alert zones. So if you want to, say, alert for specific stations, say you use the red line most frequently, you can set up that alert zone so you can just be alerted to incidents that happen on that line, if that's what you're concerned about. So we designed this to be as dynamically to be a dynamic system that can update in real time, that a user can get the most value out of. And that leads us to our final feature, the chatbot. So this is a generative AI chatbot that's powered by a retrieval augmented generation system. So all the previous analytics that we've done, all the facts and figures, the predictive analytics, all that data is taken and it's put into what's called a vector database. It's a database of ones and zeros. And from this database, we can create conversational responses. So the user will input a question, and those questions are turned into ones and zeros embeddings, and it'll find data that's most similar to that response. So all of this entire generative AI system is hosted on a Railway cloud environment, in a Railway Docker container cloud environment. And it can be transferred to any other cloud environment depending on which cloud environment we think is most appropriate, but we chose this one for simplicity. And this server, cloud server, interacts with our front-end interface. So we submit a question here, it sends out a response or the question, and we receive a response based on all the data that's constantly updating in near real time. So with that, let's ask it some questions. So to help the user with submitting prompts, we added some example questions here. So let's just click on this first one and see what it says. So when we ask it, what are the stations near me? It comes back and saying the stations nearest to you or current location are Noyes, Foster, Central, and Davis. The same stations that are on the map tab. And so let's ask it a few more questions. I have some prepared questions here. So what are the total number of crimes today? The total number of crimes today on Chicago Transit are 13. This matches what we see in the dashboard. And the idea being that a user can go to the dashboard and look at the numbers there, or they can just interact with this chatbot. There are multiple options to be able to do so. And let's ask it another question. So what are the total number of traffic accidents today? The total number of traffic accidents in Chicago today is 365. It's also matching what we have on the dashboard. Now, one more question, just for demonstration purposes. What's the safest line last 7 days? Say you're a user and you want to know the safest line to travel on. You can ask it a question or a variation of this question. So the safest line last 7 days is purple and yellow with 1 incidence. So questions like these could help the user to learn more about the Chicago transit system, to make more informed decisions about what lines to take and when. And it's also important to note that this generative AI chatbot is also integrated with the dashboard, so you can ask it more analytical questions.
Thanks, Derek, for walking us through the demo. Let's wrap things up with a quick summary and our recommendations and the next steps for TransitGuard. So TransitGuard combines the power of data science with the urgency of public safety. By analyzing 10 years of crime, ridership, and traffic data, we've built a platform that can predict risk, highlight danger zones, and deliver real-time alerts to both the riders and the city staff. It's not just analysis. It's a working system with a live dashboard, mobile app, and Gen AI chatbot that can make safety information accessible to everyone. TransitGuard helps the CTA move from reacting to problems to preventing them, and it's ready to grow with live data feeds and expansion to other cities. We believe smarter tools lead to safer transit, and that's exactly what TransitGuard delivers. Building on that foundation, we've outlined several next steps to help the CTA move from reactive safety management to a predictive data-driven approach. Based on our analysis and development work to date, we've identified 6 actionable recommendations to support the Chicago Transit Authority in continuing that transition. First, we recommend enabling real-time data integration into the TransitGuard platform. Currently, the system operates on historical data, but connecting to live feeds such as real-time 911 dispatch, CTA ridership sensors, or street light outage APIs will allow the platform to deliver live alerts and stop-level risk forecasts, providing actionable intelligence at the moment it matters most. Second, our findings clearly show that rail infrastructure, especially trains and platforms, are the most frequent crime locations, despite carrying fewer riders than buses. Therefore, we strongly recommend prioritizing rail stations for increased staffing, security camera upgrades, and physical infrastructure improvements such as lighting, signage, and visibility enhancements. Third, we suggest deploying the TransitGuard dashboard internally at the CTA, where it can support real-time patrol scheduling and dynamic resource allocation. The dashboard is fully functional and provides daily and weekly trends, risk scores, and heat maps that can assist supervisors in optimizing safety coverage and minimizing blind spots. Fourth, we propose launching the TransitGuard mobile app for public use. The app will allow riders to receive push notifications for safety alerts, view risk ratings at their station, and use in-app reporting tools to notify CTA or police of suspicious activity in real time. This empowers riders and improves incident visibility. As the platform grows, we recommend regular retraining on all predictive models. New patterns in crime, ridership, or city events can shift the risk landscape. Updating models using recent data will keep our forecast sharp and responsive to seasonal or neighborhood level changes. Lastly, to deepen rider engagement, we advise expanding use of the generative AI chatbot. It provides fast, accessible answers to rider questions like, "Is this stop safe right now?" or "What incidents happened here recently?" without requiring users to interpret dashboards or maps. Integrated within the app, it can also deliver context-aware alerts and safety tips, making the platform more approachable and trusted by the public. Taken together, these steps position TransitGuard to serve as a core component of the CTA's safety modernization strategy and to scale into a citywide or multi-city transit safety solution. TransitGuard isn't just a Chicago solution. It's a scalable, investment-ready platform designed for national impact. From the ground up, it was built with the modular architecture that makes it easy to deploy in other cities. Everything from the back-end infrastructure to the front-end interface is configurable. We're targeting major transit markets like New York City, Los Angeles, Philadelphia, and Washington, D.C., where issues around safety, staffing, and infrastructure mirror what we've seen in Chicago. These cities already have the data that we need, and TransitGuard is ready to use it. The platform supports seamless local data integration, pulling in crime reports, ridership feeds, and contextual information like lighting outages or traffic crashes. This makes TransitGuard a plug-and-play safety solution for city agencies. It's also fully customizable. The dashboard and mobile app can be rebranded to align with any city's transit system, maintaining a consistent experience for riders. TransitGuard helps cities reduce response times, optimize patrol deployment, and rebuild public trust in transit, while offering investors a platform with repeatable deployment potential and strong public sector demand. With the right partnerships and funding, TransitGuard is ready to scale into a nationwide platform for smarter, safer, and more equitable mobility. Thank you for your time.